Okay, this is CS252, the Advanced Programming Languages class. I'm Kai Horstman. So I want to give you a pitch today as to what's going on in the class. Can I just have a show of hands who is already registered? And who wants to add? Alright, so so I'm going to go through what we want to do, and hopefully that'll get everyone all excited about it, and then we'll start in earnest the next Tuesday. So I'm kind of assuming that people had an undergraduate programming languages class wherever you got your undergraduate degree from, and that you've seen more than just C++ or Java. So you probably have a little bit of an idea of what's out there in the space. But really, right now we're in this time when people are dissatisfied with what they can use right now. So on the web, I got this a few weeks ago from D-Zone. This guy said, what programming language should I learn next? And he has this little spreadsheet or this little decision tree where he says, is it about the money? And if yes, do you like Microsoft? Then you should study C#, and otherwise you should study Java. But if it doesn't have to do with the money, then he says, do you want to do mobile development? Are you an Apple fan? Then Objective-C, and otherwise Java, so you can do Android. And so he goes on like that. So it's all in good fun. But the article was pitched to people who really kind of see the limits of what they're doing right now and who want to learn new things. And so why are people dissatisfied with Java, C#, C++? And there are kind of three big topics that they're unhappy about. Concurrency. All of those languages handle concurrency very poorly. And concurrency is like the next big thing that we all need to get much better at, because, as you know, what's happening with processors. Now, life was easy when I was young, and you'll never have it as good, because when I wrote a program that didn't work very well, there was only one thing I had to do to make it run faster. Wait. Next year, the next generation of processors was faster. In 3 years, it was much faster. And so my program all of a sudden ran fast, and I appeared to be a genius. And nowadays, you can wait for as long as you want. Like I was looking, should I buy a new laptop? I tried out a new laptop. It didn't run any faster. Windows was still slow as molasses. Why? Why didn't they run faster?
Limitation of the language.
Because they are not designed to work on multiple processors. So
Yeah, but why didn't they just give us faster processors?
There's a limitation. There's a hardware heating limitation.
Right, that's right. So you're exactly right. It's the heating limitation. They would melt. And so they can't build them faster. So they give us more. So now we have quad core, 8 core, 16 core, and the programs that we write are not really designed for that. So we're going to be talking about how can one design programming languages that try to take better advantage of that. So kind of my analogy is if how many of you are C++ programmers? How many of you know some C++? Okay, so a good fraction of you know C++, and I guess you'll probably agree with me that the worst part of C++ programming is memory management. That it's always a hassle, it's always dangerous, and if you do it wrong, your program will either consume too much memory, or it'll just act badly if you mess it up. And so the single biggest reason why people moved to Java at the time was Java had garbage collection, and people loved not having to worry about where the memory came from. So if we could have a similar advance with concurrency, where concurrency would be kind of an automatic feature, and would automatically look at our program and distribute it over multiple processors, that would be pretty cool. It's not as easy to do, and so we'll see what people are attempting with that. Another reason that people have switched programming languages is web programming. So if you've ever tried to write a web program with, say, enterprise Java, I mean, it's possible. People have lived to tell the tale, but it's a pain in the neck. And it's partially because, for a number of reasons. One of them is that web programming is so unnatural that the user submits a request, and then the request needs to be processed, and you need to send a response back to the user. And then you have to wait this indefinite amount of time for the user to do the next step. And so any kind of logic that you have in your mind as something nicely sequential, step 1, step 2, step 3, step 4, is broken up into these itty bitty bits of pieces. And what could a programming language do? So I'm going to show you a programming language that handles that brilliantly, where you, as the programmer, you program as step 1, 2, 3, 4, and that breakup is handled completely automatically. The other thing of web programming was just the sheer tedium of it, that you had to generate the web pages, you had to deal with the database, and you had to string that all together. And there's one language in particular that addressed that part very nicely, and that language is Ruby. Now, no one gave a care about Ruby at all. Ruby had been in existence for 10 years until this one very smart guy, Heinemeier Hansson, wrote this web framework called Rails. So, and some of you may have heard about Rails, and some of you may have used it. And Rails, in a way, makes it really, really easy to do this one particular problem domain. So it's very well adapted to the domain, and it only succeeded because Ruby made it possible to write such a thing. You could never write Rails in Java because Java is not sufficiently malleable. So if you wanted to do that kind of thing, if you wanted to do a rapid development web programming language, Ruby was amenable to that, and Java isn't. So what does it take to build programming languages that give you that kind of domain flexibility? So that's another thing that people are really interested in right now. So just from a practical point of view, so these are probably the three things where you see a lot of interest in programming languages right now. So the other reason why people learn new programming languages for students and professionals is that, and that's something that's hard to understand until you've really experienced it. When you learn a really strange programming language, one that's completely different from everything else that you've seen before, it changes the way you program in Java or C++. Because out of a sudden you can see things, you can see patterns that previously were hidden from you, and you then are unhappy because it's difficult to express these patterns in Java or C++. But still, you can, with some amount of trickery, you can do that, and then you can write more powerful programs. So, and this is something that when you read blogs from other people who learn exotic languages, they will tell you about it. But you have to experience it yourself, that you're a better programmer in your mainstream language by knowing what is possible in other languages. This is something that's generally true for the human mind. There are linguists who believe that what you can express in your language can limit what you can think about. So they study primitive cultures that only know Java, that only know whatever, some language that they speak in the jungle. And so they claim that those people, there's certain things that they cannot conceive of because they can't express it in their mind. And so the same thing is true for programming languages. So the other thing that's an interesting and I think important skill is you're going to learn, for better or worse, to learn a new language quickly. Because we're going to be doing several programming languages in a span of a few months, and you have to get up to some level of speed where you can do your homework, write lab programs in those languages. And so you're going to learn that when you learn a new language, how you can leverage what you already know, how you can skip past the boring parts and jump into the interesting parts right away. And that's an important skill, because this will happen to you. You're going to join a new project, and they're going to say, by the way, you have to learn Objective-C by Monday after next, or whatever language it is that they're going to be using for a particular thing. So those of you who've done some iPhone programming, you had to learn Objective-C, and I don't think they gave you a year for it. They just said, it's kind of like C and kind of like Java, and here's the book, and figure it out. And so if you've done that a couple of times with other languages, then that's going to become more natural and less scary. And so if you had a job interview and you're being interviewed and they said, and by the way, we're using Python and you have zero experience in Python, then you can honestly say, well, I have zero experience in Python, but I've learned Haskell and Scala in 2 weeks each. Not all of it, but the important parts. And I was able to do something, and surely then I can write off Python. Then you have something you can talk about with a recruiter. And so that's a useful skill. But so if you have that kind of experience, you can leverage that. And so the other reason why you should care is you're having a career in front of you that's going to span, hopefully 30 years, 40 years, whatever. And in the first half of your career, in the first 15 to 20 years, and once those 15 to 20 years have elapsed, C++ and Java will be utterly and completely dead. They will become what is now COBOL. There will be a few people who will make a profitable but boring living maintaining legacy programs that were written in C++ and Java. Just like today, there are a few people who make a profitable but boring living by maintaining COBOL programs. And so if you look yourself in the mirror, you can answer that question: do you want to be one of them? And in that case, you should learn more about C++ and Java. But more likely, you're going to be using an entirely different language. And I wish I could tell you what that language is. But I don't know, and you don't know, and no one knows what's going to be. These things change quickly. And so what you want to know is you don't want to have an in-depth knowledge of one particular language. You want to know what makes languages tick. What is the design space? What different phenomena can happen in different languages? So when someone remixes these things into the next big thing, that you can, within a matter of weeks, pick this thing up. And if you're lucky, you can write the core foobar. Foobar is the next programming language, and you can do really well with that. And this actually happened to me, that when Java first came out, I looked at Java and said, Java, Schmava, who cares? And I looked at it as a garbage collection. It's object-oriented, but it doesn't have multiple inheritance. I knew enough about other languages that I could size it up quickly. A couple of days later, my friend gave me a call and said, remember what we were talking about Java? We're going to write a book about it. And I said, Gary, you don't know Java. I don't know Java, but I have a contract. So that's what he did. He took the general assessment that we had to the publisher, and we had a contract, and that book literally sold 1 million copies. So literally. So so sometimes you can be at the right place at the right time, but you have to be prepared for it. You have to know enough about the general gist of programming languages to take advantage of it. So COBOL. Remember COBOL? I don't know if any of you has ever programmed it. I actually never have. It's as old as I am, and it was created seriously with an interesting goal in mind, namely that the English-like syntax should be such that a manager could read your program. Now that's a stunningly stupid idea, right? I mean, if you work somewhere, would you want your manager to read every line of the stuff that you code? But that was the idea that they had at the time. Now in 1997, not that long ago, right? 80% of the world's code was written in COBOL. In 2002, that's what, 10 years ago, there were more COBOL programmers than there are Java and C++ programmers combined. 10 years ago. Now, of course, it's gone. COBOL then was replaced, this is an old slide, by Visual Basic. What's happened to Visual Basic? Right, it's been replaced. So languages change all the time. And so it's kind of a poster child of something that you thought it was huge. It was unkillable, and 10 years later, it's just a shadow of its former self. No, C++. When it first came out, everyone looked and says, gosh, this is really complex. But within a few years, everyone was programming. Everyone claimed to be programming in C++, and what everyone was actually programming in was a tiny subset of C++, where they took C and C in and C out, and maybe a class or two. And then eventually the learning curve got better, and so now they're at all sorts of parts in the spectrum. So there's a new version. Oops, I need to update this. It's just been approved. C++ 11 has been approved like a week ago. It's very complex, has lots of great support for libraries. It has some very, very basic support for multi-threaded. And it's so it's a very powerful language. And for a while, it was kind of the king of languages if you wanted to get anything done in either operating systems or application programming. People wrote actual application programs in C++. It's inconceivable today, but they did that. And then, of course, it got replaced with good old Java. And so Java was probably the most stunning phenomenon of a language coming from nowhere to adoption very, very quickly. And so within a couple of years, just about everyone who did application programming, either on the desktop or on the server, abandoned C++ and moved to Java just because it was so much simpler. There was a rich library, And this is mobile programming in Java. This is Enterprise Edition. But then people started hating Java. This guy here, this was taken from an article by Bruce Tate. The article's name was "Don't Make Me Eat the Elephant Again." What happened is he had written one too many Java EE programs. And so if you've ever done any Java EE, you know the sentiment. That there's a lot of boilerplate that you have to do the simplest thing. It's a very powerful framework, but it's not very programmer friendly. That you just have to as a problem, you just have to write a lot of very boring code in order to get going. They've simplified that to a good degree. EE5 and EE6 are much better, but still, it's not an easy. It's not as easy as it should be. And the problem is Java. Java is not malleable enough. It's not rich enough to make you kick out the boilerplate. Other languages are, and we're going to see some of those. So Java is not what's called the end of history. People really thought for a while that it would be. If you go back 10 years ago, there was a great deal of complacency. People kind of felt that they had arrived. Maybe Java wasn't perfect, but it was so near to perfection that people just kind of weren't that interested in programming languages anymore, and they thought it had arrived. The End of History is the title of a well-known book that came out 10, 15 years ago, where this Professor Francis Fukuyama argued that Western civilization and the capitalist system has dominated the world, and that was going to be the point to which everything would converge. Everything would look like America. And as we now know, of course, history has marched on, and this country may well be left behind, and something else may happen. So one shouldn't count on the end of history. And so the other thing that we now notice is that the Java story for concurrency is not great. Java concurrency was invented when, well before people were concerned about multi-core, when the model for concurrency was lots of users for short blips of time hitting a web server. And that's an important aspect of concurrency, but it's not the only thing. And the other thing that, of course, is sad about Java is that client deployment is not working as well as it should. If you look at your desktop, how many Java apps do you actually run? Like you and I run one, Eclipse. But what else? And this for what was supposed to push Microsoft off the desktop, so that's kind of sad. And there were many technical reasons why this didn't really work out. And then operating systems have been enhanced, and the library is kind of falling behind. And part of that was, of course, the history that Java was then maintained by Sun Microsystems, and Sun ran out of steam. And then it took Oracle for a long time to pick it up, and who knows what's happening now. But now there's a very conservative evolution of Java. You've probably noticed Java 7 came out a few weeks ago. And what's new in Java 7? What is the most exciting thing that Java 7 has to offer for the masses? Name one feature in Java 7. Oh, it's Google. Come on the internet. Yep. So here you find a complete list of features, and let's see if someone blogged about it. Here we have a blog. Someone says, okay, Ant, what does he want to point out as the most exciting feature? Strings in switch. Ladies and gentlemen, you can now use strings in a switch statement. That is not what I would call rapid advance in language technology, right? So, and that is the most exciting feature in Java 7. So Java is kind of progressing at a very slow pace, and what you have is an explosion of new and interesting languages. So in the slide I say the Cambrian explosion. If you remember your biology class, a long time ago, and I don't remember when, in the history of the Earth, there was this phase where out of a sudden a huge number of life forms evolved, very strange looking creatures, and then they, a few hundred million years later, vanished again, before the dinosaurs ever roamed the Earth. But you had like this period where out of a sudden, a huge new number of creatures sprang up in a very short amount of time. So we have that in languages. I have a list of languages that you might see. And so I look at the site dzone.com several times a week because it's kind of a good aggregator site for blogs that people write about what interests them in programming. And so these are regular old programmers, not programming language fanatics, but people who code for a living. You can kind of see what ails them. Here we have something about CSS3, GitHub, a bunch of JavaScript libraries because they're all web designers, something Java EE6 and NetBeans. Griffon is something that uses Groovy as a library. Groovy is a programming language. And as you go through here someone talks about something to do with Python. Every week you can see a dozen languages or so mentioned. Here's someone tired of getters and setters and has a Java add-on. Now we're going to have 20 articles about Steve Jobs. C#. And so when you look at the kind of languages that are mentioned there, you see a lot of Ruby and Groovy, the P's, Python, PHP, and Perl, JavaScript, quite a lot of that now. Java FX, I guess, there was a flurry a while ago, but not so much. Flex, the same thing, those seem to be waning. On a given week, there's going to be several Scala articles. I haven't seen anything about Newspeak for a while, but Clojure kind of competes with Scala for attention by the in-crowd. And so there are all of these different languages, and some of them are optimized for very fixed tasks. Well, you would learn ActionScript or Flex if you wanted to do that kind of Adobe, what's that thing? Flash program. You would learn PHP. Okay, I have no idea why anyone would want to learn PHP, but people do. And some of these languages aim to be the next language that you all should be using. Scala, for example, wants to be your next programming language. And it might be. So there's this huge interest right now that people are saying, what comes after Java? And no one knows. But people are trying different things. Just a few weeks ago, out of two different organizations, groups tried to come up with some proposals for language that's halfway between Java and Scala. They said Java is obviously not going to cut it anymore. Scala is pretty complicated. Can we do something in between? So within weeks, two different organizations proposed something, and that'll come to some fruition in the next months or so. And again, if you're in the business of selecting technology, you want to have the ability to cut through those claims pretty quickly, and that's where it really helps to have some knowledge of language theory. All right, so like I say, the challenges that are ahead here are concurrency, and that's the biggest problem that everyone's facing. That concurrency is the new normal. You're going to have to expect that the processor that your program runs on has more cores than anyone can keep busy, and you need to figure out how to do that. Or one needs to figure out how can one design a language so that the programmer doesn't have to figure out too much. Now, I say it would be nice to have automated concurrency, just like you have automated garbage collection. And for some problem domains, that's actually possible. So as an example, when you use Java 7, one of the more interesting Java 7 features that you will never see advertised anywhere is that if you take an array and you run sort on it, it's automatically parallelized. So if your processor has more than one core, just calling sort automatically uses the second core. And that's kind of nice, right? So for tasks like that, one can do it. Scala has a much nicer story to tell there, where not just sorting, but any kind of algorithm that you can express in a certain way can be automatically parallelized. And so that's a good thing. And then the question is, what if you don't have that kind of regularity? Sort is very regular. Iterating over a collection is very regular. How can you deal with those situations? We're going to look at several proposals that people have. And so right now, of course, you can implement more concurrent programs, but generally you have to use locks. And most students have had an operating system course where you maybe did the Dining Philosophers or something like that, and scratched your head and said, this is all too complicated. and what's the point anyway? And so then when you get to do some professional programming and you have to debug things with logs, then you're going to see that this is really a nasty business. It's very, very difficult to do this right. And so some better paradigm has to come up. And so we're going to spend a fair amount of time on that. The other thing is this issue of agility, that when you look at a Java program, Java was purposefully designed to be easy to read. So when you listen to Gosling, he will say that C++ they felt was hard to read because the syntax was awkward and stuff. And so they've taken away features in Java so that programs would be easy to read. For example, in C++, you can overload the meaning of operators. You can say if you have two big nums, for example, A plus B should add the two big nums. In Java, you can't do that. And so they took that away because they felt some programmers out there would be writing hard to read code by using overloaded operators. But as a result, Java is also very verbose. That the same thing that you can express in something like Ruby or Scala in 10 lines will take 20 to 30 lines in Java. And now you might say, big deal, but someone has to read through those 20 or 30 lines. And it's not just that you have to read through them, that as you read through them, you have to scan and say, are these the same boring boilerplate things that I have seen a million times? Or is there a trick somewhere? Is there a wrinkle? Did they do something slightly different? And that takes some amount of time, and it's unproductive. There's ample research that shows that productivity of programmers is roughly proportional to the number of lines of code that they write. So every programmer can write so many lines of code per day, debug lines of code, and it doesn't much matter which language. That can be assembly or C or Scala. And so if you can cut down on the number of lines of code, that should make programmers somewhat more productive. Seems utterly unintuitive, but that's how it is. And much of it is that we read more code than we write, and we need to read other people's code, and if that code is short, it's kind of faster to read. Of course, at some point, there's a tipping point. If you cram every code in one line with no blank space, then that's bad too. But so Java was made to be easy to read, but it turns out the repetitiveness works against it. And so people kind of, also they hate it. They have to slog through all of that stuff. Eclipse helps a great deal. I do half my coding with control space. But still, I have to read everything that I generate. And then, if you need to make changes, and if you have a lot of boilerplate, where you have getters and setters here, and you have some XML configuration here, and you have more getters and setters that need to match the other ones, that usually exceeds what the refactoring tool can do, because the refactoring tool knows about Java, but it doesn't know about your library and your XML configuration. And so you have things that are very brittle and very hard to change. So Ruby on Rails here really is kind of the anti-Java in this case. It's very agile. It puts things together that need to be changed together. It has this principle, don't repeat yourself, the dry principle, where they say everything should be mentioned only in one spot. And that's the opposite of what happens in a big Java framework, where everything is mentioned here and here and here, and all has to be just so. Don't get me going with Java server faces. If I had $1 for every time that I named something here one way and there another way, and then it takes 5 minutes for your app to come up, and then you go duh. And so many 5-minute and duh cycles, and your day is done. So, and so what does it take to make a language agile? Rails programmers have a high price to pay, 2 high prices. Number one, they have to learn Ruby. And Ruby is weird. You'll see. You'll see why I say that. And number 2, Ruby is not strongly typed. So they're going to face a lot of errors during development that the compiler can't catch. So is there a better way of doing it? Can you have agile in a language that's sane, that has better compile time checking? And so we'll talk about that. The other thing is that it's kind of a curse on the world that you have these little languages everywhere. I've seen projects where you use JavaScript for, of course, on the web page, where then some Flash components, they use ActionScript for that, and then someone puts it in their mind to use Lua, whatever goes on in their mind, I don't know, but they do. And then, of course, you use Bash for some automation, and then they use PHP to write the web pages, and then they have some Java backend. And so you have all of these languages, and it makes it hard to staff, because now someone goes on vacation, and you can't just tell the Java guy, well, why don't you deal with that Lua code and So it's kind of unfortunate. Also, it means that if you are actually on your own working on such a project, you know that it takes a certain amount of time. It probably takes between 6 months and a year to be really fluent in a language, where your fingers think the language. You know, at this point, I would imagine that either in Java or in C++, you can program away, and half of the stuff your fingers just do on autopilot. I mean, that's what happens after having done one language for several years. And to get that in another language, it takes a fair amount of time. And so it seems kind of a waste to have to climb that curve again and again and again. It would be better to have one language that can span a wider spectrum. And so the more modern languages try to be built so that they can be used both in the small and in the large, so that you don't have to have the need for these mini languages every time. So like Scala, for example, or even a traditional language such as Lisp or Scheme, will have mechanism where you can embed littler languages into the big language. And then that way, let's say, right now I'm working on something. I need to do a lot of drawings for a book, and I'm not going to sit there with Visio and make them all by hand, because I have to make hundreds of them. So I have a mini language that assembles rectangles and arrows and stuff into bigger diagrams. And I figured, what could I do? There are existing languages that kind of do that, and they happen not to quite do what I wanted to. And so, of course, I figured I'd do my own. But I wasn't going to write a new programming language. I'm putting it inside Scala because I know Scala. And that way, all of the stuff that I know about Scala, and how do collections work, how do loops work, how do methods work, how do function calls work, I can use that. I don't have to relearn it in another language. Whereas there's another package where that's in a slightly different level, called processing. You may have heard about that. It's something that the people in the art department love to use for like special effects drawings and stuff. And it uses its own little language. And so that seems kind of insane these days. It seems to be much better to have languages that can adapt themselves, that can morph themselves into these domain-specific languages. So we'll be talking about those. So those are kind of the three big themes. So I taught this course last semester in Vietnam, where I was on sabbatical. And before that, someone sent me this book by Bruce Tate called 7 Languages in 7 Weeks. So Bruce was the guy who, the one with the elephant, who wrote that article. And so he's a well-regarded speaker in industry conferences and stuff, very practical kind of person. And so he said, he wrote this book to kind of teach the basics of a whole bunch of different languages to span the spectrum to professional programmers, and one a week. So I looked at that, and I kind of liked the idea. And what I didn't like so much is that he went a lot into syntax. So he had, how do you do loops and stuff in Haskell? How do you do them in Ruby? How do you do them in Scala? It was kind of the same thing over and over again. And I figured, those guys are just industry programmers. Here we have graduate students who, they can recognize a concept once they've seen it once. I don't have to do the same thing over again. So don't get it's a nice book. If you want to get the book, by all means get it. But we're not following it exactly. But I'm kind of following the idea of saying, let's look at a few of the key languages that show different aspects of stuff that one can do nowadays. And so we're going to be digging much more deeply into the mechanisms that make interesting things happen. And we're not really going to be worrying much about basic syntax. And so actually, in the Ruby module, my students last semester, they said, okay, so we had 2 lectures on Ruby, and then we started looking at metaprogramming. And those 2 lectures, when we compared them against the online manual, how come you jumped from chapter 1 to chapter 20? And the reason was that chapter 2 talked about loops, and chapter 3 talked about branches, and chapter 4 talked about functions, chapter 5 talked about arrays and that kind of stuff. And we all know how to do these things. We're just unfamiliar with the Ruby syntax. And so that's just what's going to happen. So you're just going to kind of copy and paste and guess the Ruby syntax for these basic things. But we're going to be really keenly interested in how does it work to make metaprogramming work. And there we're going to be spending more time. So you're not going to be an expert Ruby programmer after 2 weeks. But hopefully you'll be able to kind of speak Pidgin Ruby with the basic things and become a bit of an expert in some of the more advanced features. Because those are the ones that even though you may never ever do Ruby again, it's very interesting to see how can a programming language be so flexible, how can it be so malleable, what mechanisms go on, and we're going to be using Ruby as an example because it's easier to see something with an example than just in theory. So, so most of our focus is not going to be an expert in any of these languages, but to look at what's interesting, what's different about them. And so we're not going to look at how do Ruby do arrays, because other languages do arrays, we know arrays are boring. We're going to be looking at what does Ruby do that no other language does in just that way. The other thing is we're going to do a mixed lecture lab, so you're going to be bringing your laptops for every lecture. I'll be lecturing a little bit less than today, and then there'll be a lab right away. And so that, because when I tell you something and you listen to it and you look at the slides, it all makes so much sense. It always does. And then when you do the first lab assignment and it says, you know, interleave these two arrays, and then you say, holy cow, now what do I do? There was no slide on this. And so that's when you start having to think about it, and that's when you have questions. So we'll do lecture, lab, and then after the lab is over, in the last 10 minutes or so, we have a discussion as to what did it all mean, what did we learn from the lab, that kind of stuff. There is a more or less weekly homework. So what one of the things that I always dislike about homework is that I assign some homework project, and some people who should remain unnamed, hopefully none of you, then wait until a day before it's due, and then they say, gosh, isn't there homework due tomorrow? And then they look at it, and then they give me whatever it is that they can figure out in a day. And it's everyone's time is wasted. My time is wasted by giving half-assed comments to a half-assed assignment, and the students' time is wasted because they didn't really learn anything from this. And the way you learn something is by taking a complicated problem and thinking about it day in, day out until the solutions finally come to you. And it's not just usually one thing. It's one thing leads to another, leads to another. And each of those kind of mental breakthroughs takes a day or so. So I'm going to make it so that you have to submit every assignment in a couple of batches, that I want to see like your first draft and your second draft, sometimes maybe 3 drafts depending on how the structure is. And I'll give you all we'll just run a version control system, and you just check in what you have. And if I see a steady stream of check-ins, then I'm a happy camper. If I see zero activity and furious activity the day before, then I'm not. So I'm going to be giving a grade for that there is something there in intermediate form. I don't expect the intermediate form to always work, but I'm going to be looking at how far did people get, what did they have. And that usually leads to better questions in class too, because then we have ample time to answer questions in class. Usually what happens is that the 2 or 3 smart guys who know that you need to work ahead, and hopefully there are more than 2 or 3 smart guys in this room, but and they'll answer questions like crazy within a few days after the assignment has been given. But then a whole bunch of the people who could benefit from those questions aren't really paying attention because their brain hasn't been prepared for that. So by forcing you to make more regular submissions, I hope to get past it. And again, maybe it's all of you have great habits already, and in which case it's not going to bother anyone. So there'll be a midterm and a final. Prerequisites are, of course, good programming skills. If you don't feel that you can code, you are not going to enjoy a class in programming languages. Just like, if you don't think that you can solder, you probably shouldn't be in the hardware. I have no idea. I'm not a hardware guy. But so I'm kind of expecting that you have basic programming skills, that you have had a course in programming languages where you have had some familiarity with the functional programming language. Now, that might have been a few weeks, but hopefully more than a lecture. And that when we do that here at San Jose State, the language can vary actually. Different instructors will choose different languages. So one might choose Scheme and the other might choose Haskell or Scala or something. Like when I teach it, I use Scala, and when Dr. Pierce taught it, I think he used Scheme for the functional part. When Dr. Smith teaches, I think he also uses Scheme, or maybe ML, I don't remember. So people have different preferences, and it doesn't much matter. As long as you can do basic things in a functional language, lists, recursion, then that's good. That's good enough. I just want this not to be the very first time that you've ever seen such a beast. And so I'm checking that in the prerequisite quiz. Doesn't matter what language. JavaScript would be fine. If whatever your instructor taught you functional programming in JavaScript, I'm okay with that. So the grading scheme for whatever, so there's midterm final homework. There's going to be a project. The project's going to be an individual project. I will assign topics. I said, well, there's this many people, there might be groups of two. And then I'll ask you to give some evidence of participation. There's a discussion group. You'll get some points for asking questions and for answering questions. So I meant to put that on here. Let me pull this up, because this is something that, particularly with if some of you have just recently arrived here. So this is what I told. I'm teaching a course for freshmen, for kids who've never done any programming before. Freshmen, yeah, they don't know what a keyboard is. And so whenever I teach that course for the freshmen, what bugs the heck out of me is that they're stuck, and they don't like it, and so they just do something else. They go and have lunch or something, and they don't ask any questions. And so I have to tell them that it's important to ask questions. And when I taught this course in Vietnam last semester, I had the same problem. Those students, they would never ask any questions. And I would ask them, saying, why don't you ask a question? And they said, well, but I don't want to have everyone know that I'm stupid. And that was a reasonable thing to think about 15 years ago, maybe. But nowadays, I cannot imagine doing my job as a researcher, as a book author, as a teacher, without having the entire world know how stupid I am. So what I did here to demonstrate this, I put a couple of links to some questions that I asked. So here's good old me saying, I want to do this, and I can't figure out how to do it in Scala. The entire world knows that Horstman does not know how to do this in Scala. They know, they laugh. Well, what choice do I have? I don't have the time to figure everything out by myself. I don't have the knowledge to figure out everything by myself. I have to ask questions. And I would imagine when someone finds this 5 years from now, they're not going to hold it against me that 5 years ago I didn't know how to do arcane thing X in Scala. Hopefully they will give me credit that I have grown up since then. But it's there. It's forever. It'll never die. You'll always be able to Google this question and 100 other really stupid questions that I asked. I mean, it's like there's so many. Here's another one. Or just as stupid. Please have a look at the following code. I can't figure out why these calls aren't obedient. And it turned out actually that was a better question than I had thought at first, because several other people got the answer wrong. And their wrong answers are now forever memorialized, and anyone can find them. And so there we have in a discussion of where people had, you can read through this. I'll put the link on these slides too, where people had sometimes totally inane answers that a little bit of simple experimentation, which yours truly has of course then done because he was so confused, could disprove. But they put them on there. We had a frank discussion out on the open internet about something. So, and we do that not because we love humiliating ourselves in public, but because we have no choice. What one studies today is so complicated, and there's so much of it, and so much more comes all the time, that if we don't work together and find communities where we help each other, you can't compete. So I have a book, I have a deadline for this book, it has to be out in a few weeks, and I just would not get it done in time if I didn't ask the community for their help and their expertise. When I was coding and need to get stuff done, my boss says, this deadline. If I just say, well, I'm not going to ask a question on a discussion group because otherwise I appear stupid, I mean, it wouldn't have worked. A couple of years ago, I helped out with some mobile phone project, and I knew nothing about the platform. And so I just asked lots of questions, which you can still find on the BlackBerry forum, which mercifully Google doesn't index. But if you log in, you'll see all sorts of silly questions. And so you need to get over the hump if you're not already there, that you ask questions. So you should have gotten an email, those of you who are registered, from this site called Piazza, that someone had highly recommended to me as the killer site for student discussions right now, so we're going to give it a try. It was actually done by a graduate student in Stanford, or an undergraduate? Anyway, a student at Stanford who is now trying to turn this into a business, so I thought it was kind of interesting. And she sent me an email a few months ago and said, check it out. And then in the meantime, it's been growing quite nicely. So we'll see whether it's any good. It looks pretty nice. And so when you have a question, ask the question. And I will, at the end, I will count how many people ask questions. And I will not read the questions. I will not remember whether they were dumb questions. You can get a better grade by asking lots of really dumb questions. A better grade. You could answer them. And I'm not going to check whether your answers are right. You could take every one of the dumb questions and answer it wrong, and you'll get a better grade. So go for it. You'll confuse your classmates. So, no, I mean, in the end, the social dynamics are so, and people do tend to try to help each other. So why do people answer my dumb questions on the Scala mailing list or the BlackBerry mailing list? In the end, they do it because it's come to be this big social contract that if someone answers my questions, I feel kind of obligated to answer some of the younger or even more inexperienced people's questions, and that way the real experts don't have to do that. So usually the experts, they will look at, say, which question are they interested in answering, and if the question sounds kind of intricate or makes them look good when they answer it, they will spring into action. If you post a question and say, well, my homework is to interleave two lists in Scala, how do I do that? Chances are no one's going to give you the time of day on this particular group, but there may be. There may be another community of students where that's going to do you any good, and you can certainly ask questions on the Piazza group that we have, and so as long as you don't totally give the answer away, by all means, give tips. So with the Vietnamese students, it took them a long time to get to the point where they gave each other tips, but eventually it did work out. So hopefully here it'll be a little bit faster. Yes, I asked them, why is it so hard? It was just totally against their education. Their education was, you sit in class, someone tells you words, you don't understand a word of what they're saying, but you all dutifully write it down, and then you think about it later. And then I asked them, do you think about it later? No. So why were they in class? They've always been in class. It's always been like that. So it was very interesting, very different way of teaching. And so it took me a while to get them. They were very, very good, so make no mistake, they were excellent. But they just had an ineffective way of dealing with learning stuff. All right, labs. So short lectures, labs, review. No lab today because you don't have a laptop yet, and people with adding and stuff. You'll work with a buddy. I will probably assign the buddies. That's what I'm doing in the other class. That generally works better. You need to bring a laptop. Any old operating system that fits on a laptop will do. And so in each day, one of you will code and the other one will type up answers. You've undoubtedly heard about pair programming, where you only have one keyboard and two people talk about, and one person is kind of the driver and the other one is the coder. And people who do it say it's great. It forces you to first think and then code, and four eyes see more than two, and when there's a bug somewhere and one person is all right wrapped up, the other person can kind of see it. To me, it seemed a little hardcore, so I didn't want to do that. Partially because I feel so uncomfortable when I don't have a keyboard in front of me, and it doesn't feel natural. So I figured it's okay if both of you have a keyboard, but it really does make a lot of sense to have two people work on one thing, because you see things together that you would not see on your own. So my analogy is always, one of the things that I'm very, very bad at, except teaching, is home repairs. When something is broken in the house, it's never a pretty day. And so I have no patience with the stuff. And so when I do it by myself, I can never fix anything. But when I'm with my dad, who also has no patience with it and who's terrible at it, when the two of us work at it together, somehow it always works. Because I give up after 15 minutes, but he still has enough energy left to talk me out of giving up. And then after 20 minutes, he's totally demoralized, but I have a second wind of energy because it actually worked for a while. Something worked, and I'm hopeful again. And so the two of us together, because we have different intervals in where we give up, we can finish a project that neither of us would be able to finish on ourselves. And that's very, very common and when you learn something. So we're going to be doing that. So that does mean you really have to kind of show up for every class meeting, because otherwise you're going to be letting down your buddy who's in it's going to feel lonely. So the expectation is you do show up for every class. And so we switch the roles between coding and writing, so that, because probably most of you prefer coding over writing up the answers, and that way everyone gets to do a bit of each. So yeah, don't worry about the English. I don't care about English. I just care about the code and just a little bit of commentary in bullet English. Just 160 characters per observation or something. So it's just, I want to see, are you getting stuck or are you following along? If the labs turn out to be too long, then sometimes I might say finish them out of class, or if they're not that interesting, then I'll tell you it's okay to not finish them. We'll just have to see how it goes. It very much depends on just coding skills that everyone has. Software. So I'm expecting there's going to be some mix of operating systems, some Windows, some Linux, some Mac OS, and that's just fine, as long as everyone uses the same shell, and the common shell is Bash. So if you use Windows, it's not all is lost. You just need to install Cygwin, which has Bash. And so all of the instructions that I give assume that you have Cygwin installed, or if you have Linux, then you already have Bash. And if you have a Mac OS, then you already have Bash. So in those cases, you don't have to do anything particular. But that way, I can give you uniform instructions no matter what the platform is. And as those of you who run Windows will notice, is that Windows, sadly, is not the best platform for learning about new programming languages. Windows is, I'm sure, a wonderful platform for running Word and what's that thing, Excel. And that's why people are paying Microsoft a lot of money, because it's a platform for business users. It is not the best platform for programmers. And there's no law that says that a good platform for business users needs to be a good platform for programmers. And so we'll be doing a lot of work with the shell, and the Windows, like that command thing there is atrocious. And Cygwin tries to paper over some of these differences, and it does an amazingly good job, but it's not perfect. There are little itty-bitty issues, but it's okay. One gets the hang of it pretty quickly. And just when you curse Cygwin, remember that it's not Cygwin that's at fault. Cygwin tries to make the best out of a bad situation. So, and you could certainly install like a VM. You could install a VM and run Linux in a VM. If you have the memory, that's probably preferable. And that way you just follow the Linux instructions. Unfortunately, Windows by itself consumes a fair amount of memory, so if you have less than 4 gig on your laptop, then you're probably going to have a hard time getting much muscle out of a VM. But if you have 4 gig, go for it. If you're running Windows and 4 gig, install a VM, put Linux on the VM, and just use that. That's easier than running Cygwin. But if you must run Cygwin, it's all documented. I've had a whole bunch of students doing exactly that last semester, and they all cursed it at the beginning, and then they got past it. So we're going to be using Emacs, and the reason is I was pondering that last semester. I said, "Gosh, Emacs is this ancient editor, and people have bad vibes about Emacs." And so I said, I'll let people use whatever the most powerful text editor is that they like to use. And all the students said, "Oh, I love this thing, Notepad++, for example." And so it's the greatest thing. And then every time that we needed to do some heavy lifting, Notepad++ not only couldn't cut it, but didn't even get to the point where the problem could begin to be addressed. And so someone said about Emacs is that Emacs is so much better than all the other text editors. It's like the sun that not just outshines the other stars, but makes them disappear. And that actually is true, oddly enough. So Emacs is this horrible program that's hard to use, and that's like, you can see it's 30 years old, and the user interface conventions have changed. But every time someone comes up with a relatively new programming language, the first thing that someone does is make Emacs support for it. And the Emacs support always works better than the IDE support for several years. So I do a lot of Scala programming now, and the embarrassing thing is there is a Scala plugin for Eclipse, there's a Scala plugin for NetBeans, there's a Scala plugin for IntelliJ. I try them all, and every time that I actually need to get some work done, I'm back in Emacs because it works. I want to use the other ones. Emacs is ugly, but and so when the same thing with Ruby. There's a bunch of people who use Ruby on a Macintosh with, gosh, what's that thing? Who's a Mac programmer? No Mac programmers? There's a whole bunch of people who love doing Ruby on the Mac, and they use this thing called TextMate. So I looked at TextMate and said, that's just like Notepad++. It doesn't even begin to do the kind of things that the really bad Emacs plugin does for Ruby. And so we're just going to do it. And that way I don't have to forever ask, can your editor do this? Because we're all going to be using the same old crafty editor. And it'll work. The trouble with Emacs is it has a learning curve of probably about a year. And after a year, one knows everything about it, and you can never escape again, because it's just so much more powerful than everything. But in the first few weeks, it's kind of painful. I know you might say, that's a long learning curve, a year. Well, for a career of 30 or 40 years, a year is nothing. So, live with it. Version control. We're going to be using the version control for a couple of things. One is for checking in homework so that I can monitor continuous progress. And the other one is in the exams so that I can monitor that. The exams are, I guess I didn't mention that, the exams are like open book, open notes, open laptop, open everything. And open internet. You can Google for the answers. And if you find them, I will have failed. Because, of course, I Googled for it first before I put up the questions. But there is always the incremental risk that people kind of communicate with each other. And I try to make sure that you don't. But how do I know? So what I now do, and it works great, is you have a version control system on your machine, and use check-in every 10 minutes. And it's very hard to cheat. And at the same time, leave a credible trail where you check in. And once you've used the version control system, the checking in has become so automatic that it'll be fine during the exam. So that worked wonderful. It reduced all temptation to communicate, because it just, if you have an exam where there's a check-in every 10 minutes and they're all empty, and just before the end, out of a sudden, all solutions have sprung to life, you know that something fishy must have happened. But if they incrementally get more convincing, then that's kind of so. And we're going to be using Mercurial, not because it's wonderful or because everyone uses, but because it's really easy. Mercurial has. Did anyone use Mercurial? Does anyone use Git? No one use Git? Okay, yeah. See, several people use Git, right? And is Git better than Mercurial? I don't know. GitHub is good, but Git by itself, it has about the same features. It has, for advanced users, has some pros, some cons. Mercurial is dead easy, and it has this huge advantage that you can run Mercurial on your own machine without having to install much at all. You install Mercurial, and that's it. And then you can, it's just super trivial to install, and then you can clone your repository when you submit your homework or when you submit your exam. You'll see it. You'll like it. And finally, we're going to get started with Scala in the first couple of weeks. So my thinking was that you probably would like to have some warm-up with functional programming. And so Scala is this interesting language in that it's both functional and object-oriented, and it tries to do programming in the big and the small, and DSLs and all of that. But I figure we can use it as a refresher for functional. Later on, we're going to be looking at other aspects of Scala for concurrency, for DSLs. But we'll start with functional. And it's similar enough to Java that if your scheme and stuff is rusty, you're going to get the concepts in a language that's familiar to you. And we're going to be needing some of the things for the next language that we're going to get into, namely Ruby, where Scala and Ruby are going to actually look pretty similar, and it'll make it simpler to make that transition. So you need to install Scala. Here's some websites. Oh, advertisement. Yeah, might as well do these, and then before going to the prerequisite thing. A couple of advertisements, people who asked me to pitch something. So Ron Mack has this great course called History of Computing, so what happened is he was going to teach this course, History of Computing. He's active in the Computer History Museum and stuff. And then he figured maybe he could have a guest lecturer or two who would talk about some important parts of computer history. And so he sent a bulk mail to like 20 people who he thought, one or two of them might actually say yes. Steve Wozniak, James Gosling, and a whole bunch of other luminaries. And almost every one of them said, yeah, sure. And so now he had a problem that he now has to deal with all of these speakers. But so and he says in the end not all of them are going to be able to make it, but there's going to be a large number of really famous people talking to the audience. And so unfortunately he set it as an undergraduate course. And so I said, well, that's not so good. Then no graduate student will want to take it because it's an elective, not an option. And he said he's willing to open a concurrent graduate section. So if you're interested, it really is a fun course. And you could also take it as an elective, of course, but you would be able to meet people who you will never be able to meet in your life. Now, I would want to take the course, but he says I'm going to intimidate the students. I can't. And so you should definitely take that into account. So it's going to be so much more interesting than certainly more interesting than this course, but it's more interesting than just about anything else you can take. And so send him an email and say, Horstman said I could do this as a graduate course, what gives? And if he gets enough of those emails, then the secretary will open the graduate section. It might just be he just needs one or two, I don't know. So check it out. It's highly, highly recommended. And Mac is a great guy, a great personality. So I mean, it's an experience that it's a once in a lifetime thing. He's never going to get these people to do it again, because once they see, that in what bad shape San Jose State is, that it's going to go to Stanford again next time. But this time he hasn't. And then the other thing is, there's the summer university that we're having every year, and it alternates. Sometimes it's in Switzerland, sometimes it's here, sometimes it's in Long Beach. It was in Long Beach last summer, and next year it's going to be in Switzerland, Yverdon. And it's this kind of odd thing. The Swiss government funds a large part of it because they want their students to have more international experience. So in the French-speaking part of Switzerland, where they're all overwhelmed with having to learn German as their first foreign language, and then English is the second foreign language, and so they kind of feel a little isolated. And so the Swiss government is kicking in some money that they are in contact with more students. And they're going to subsidize the travel expenses. Yeah?
I'm graduating in May 2012.
Yeah?
Can I still go?
That's a good question. You might delay your graduation until the summer. I don't know. I have no idea.
So, who is the right person to ask?
Dr. Pierce. Yes. Yes, so Dr. Pierce has been running this with great enthusiasm for a while. And so it's something that at some point there's going to be this announcement coming out, and then there's only a short amount of time to plan for this. And sometimes students, they don't, then they look at it and say, well, this sounds kind of interesting, but I haven't really spent time to look for additional funding, because there's an extra expense. That they'll subsidize the plane ticket, and I think they provide free lodging or subsidized lodging, I'm not quite sure. But there's some expense from the student side, and it's for a student it can be a non-trivial expense. And yeah.
I'm sorry. What is the summer university regarding?
So it's students meet at this one place and take short courses. You get a 3-unit credit, elective credit for it.
And do we have to register for that course?
Yeah. Yeah, so it's a 180 course or something. It's kind of like the internship course. It's an undergraduate 3-unit course that, as long as you don't have other electives, you can use for your master's degree. And that's why some people kind of found it attractive, because their schedule was so they took 3 and 3 and 3 courses, and that way they were able to get out fast by planning. So if I've had one student who really managed to do this right. She came in first semester, did her English stuff, and then she started 297 and then 298, and then she took that summer course somehow, and she was out in 18 months. So it gives some flexibility in getting some summer credit when otherwise there are not that many courses offered over the summer. And it's great fun because the Swiss people are a lot of fun. Switzerland's beautiful. The instructional program is of high quality. You learn interesting, kind of off the beaten track things in a short amount of time. And so I would recommend it highly. Have a look at what they did before and see if that's something where you might want to scrounge up some extra money for. And then when the application comes out, then at least you would know that it's out there. And depending on, it's always more competitive when it goes out, when we go to Switzerland, because more people want to go to Switzerland than to Long Beach, obviously. But that's okay. I mean, it just, I think last time we've taken just about every qualified applicant. So this may be another one of those once in a lifetime things. And eventually the funding will run out because the Swiss will realize that they're spending a lot of money for an incremental gain. But hey, as long as it lasts. Yeah.
Is there some criteria, like you need to register for some amount of courses? Or?
No, I mean the way it works is they will want to see your grades and stuff because if there's more applicants than available space, they'll pick the smarter students. But you need to register for one course, whose course number I don't know, but it's like 180i. It's a 3-unit course. You get a grade. That grade is composed of the grades that you get in the various short courses that you take there. So in each of those short courses, you assemble points, and then they add them all together and curve it in some way. And I would imagine most people, it's a summer school, the grading is kind of lenient, but so I'm sure everyone gets an A or a B in the end, but it's possible not to. And it's just that there's the expense of the 3 units, of course, and more importantly, there is some travel expense that you need to budget. So it's cheaper than if you went on your own, but it's not free. Yeah, and then there is the issue that the American currency is, of course, not the strongest currency anymore. So living in Switzerland is more expensive than you would ever have thought possible. So every time when I go there, my wife looks at the supermarket. She looks at the prices of the ground beef. She just wants to die. So these two things, think about it. Those really are somewhat extraordinary opportunities that you won't find every day. The other thing that you need to do is, let's see, where I have my green sheet. I don't. Let me just open it real quick. I'm supposed to check prerequisites, and in order to make that simple for me, oops, this is the wrong. That is the wrong course. I want you all to send me a prerequisite quiz. So I'm giving you, I need to check that you have had some experience in some other programming language, that you've taken a programming language course. So I'm asking you to come up with a very simple program. And do it a couple of ways. And then since I have you, I figure I might as well see that you can install your software. And so I want to see that you have done this in a bash shell. And then the third thing is I want to add you onto Mercurial. And Mercurial has a somewhat non-standard way of doing authentication that's actually more elegant than the usual password thing. You have to generate a public SSH key. And so I give instructions on how to do that, and I want your key so I can add it to Mercurial. If you're currently registered, you must fill this thing out before the next class meeting, because otherwise I will drop you for lack of prerequisites. So it's not optional. And also, if you want to add the course, do the exact same thing, fill the thing out, and just put add request in the subject line so that I can tell the difference. Or otherwise, I'll just look in the class list and I'll be able to tell the difference. And then I'll send an add code as soon as I get it. So the way to add is to send me a prerequisite quiz. As soon as I have it, I will return the add code to you. There's obviously room for everyone who wants to add. So just send me the prerequisite quiz.
By when do we have to send this to you?
Before the next class meeting. Because I want to make sure that everyone has the software installed that we need for the lab on Tuesday. So by Tuesday noonish, so the latest. If you have any problem with the software installation, if you're already on Piazza, if you have already added, put the question on there. I monitor that thing all the time, and then I will answer it, or maybe one of you knows the answer. And someone's going to have bound to have some problem with the software installation. It's a mildly complicated setup. And or if you have problem generating an SSH key, or whatever, any kind of problem, just put it on the discussion group, and I'll take it from there. Yeah.
Where can I find the Paul 11 green sheet?
It's a somewhat you Google for Kai Horstman SJSU. Come on.
Just look on CA 42 and then change the
That'll work too, but come on, why am I not on the internet? Okay, I'm not on the internet, but it's something with SJSU people Kai.Horstman. If you Google for it, and okay, actually I'll see it here. Hang on. The awesome bar should have it. Here, and then it's here 252, and there's a link to it.
it's a for 2009.
Really?
Yeah.
I'll fix it then.
It's for 2000.
Okay, let me. Can you send me a quick email about that so I remember to fix it? Because I will have forgotten by the time that I leave the room. All right, I'll make sure you have that link going this afternoon. Well, actually, if you're already in Piazza, you can put it on Piazza.
I'm not.
Okay. I will also add everyone as soon as I have get your email with the add request, and you'll be added on right away.
So then you need to add yourself in the groups, Google groups, if it's Piazza.
No, yeah, we're not doing the Google Groups this time. It's supposed to be a replacement for the Google Groups, and they say it's a little more interactive. I don't think it's an earth-shattering difference, but I figured since she's a student, I want to help her out. And other people love it. So several instructors who I know very well, they seem to think it's the greatest thing ever. So we'll see. The one advantage that it does have is it keeps track of who asks questions and who answers questions, and so I can click on someone and say, this was a great question, or this was a great answer. Awesome. Other questions?
Can we also find the details of the prerequisite quiz online?
Yes, it's in the green sheet.
Okay.
So if I was online, which I'm supposed to be, but I'm not. Let me double check one more time. No. See, I am online here. So I'm just going to have to tell you how to get there. So you get to my San Jose State course page. You click on 252, and I will fix, in the next few minutes, I will fix the link to point to the right green sheet. And on the green sheet is the prerequisite quiz. So the other thing I can do is I could probably generate an email to everyone who's already registered, but if you still want to add, you're kind of on your own to find it. So those of you who still want to add, that's going to be part of the intelligence test to see. If you can't find it, send me an email and I'll send you a link. But I trust me. We'll all get that. That's all I have. I guess my time up? Whatever. I'm done.